Okay, so yesterday we were solving LRU cache, so today we will be continuing solving it. And before it, I will start with the merge k shorted list question. Okay, so let's hit the timer. So basically, the question says, given an array of k lists, each linked list is sorted in ascending order. Merge all the linked list one sorted linked list, return it. So basically we have an array of linked list. So this is a linked list, this is a linked list, and this is also a linked list. These all arrays are sorted, and we need to return a sorted array output after merging all of them. So we know how to merge the two linked list, and we can merge first two linked list, and we get a linked list. Then we merge that linked list with this linked list. At the end, we will be left with the sorted linked list. So I think first we should implement a function. I think my screen is visible. Okay. So we have well next. Okay, let's merge lists. Okay. What is wrong? Okay, so we need to merge these two lists. Suppose we have these two lists. Okay, so we need to merge these two lists. So what we will do, we will merge the list in place. So basically, we will modify the pointers of the list. So basically, this pointer is pointing to this pointer is pointing to this pointer is pointing to this, and this pointer is pointing to this. So we will start with two pointers. First pointer will be here, second will be here, and accordingly, whichever is the smaller one, we will add that to our merge list. Okay, suppose here one is, so we will add one to our list and move over this pointer. Okay, so now we will check uh, which pointer is which value is bigger. So smaller, so one is smaller. So we will what we will do, we will point this value, this pointer to 1. Okay, so now my one pointer, this one pointer will be pointing to this. Okay, so now I will move my this pointer here, and this pointer will be here. I will compare which value at which position is smaller. So 3 is smaller. So I will move this pointer at this position. So basically this pointer points to this to this, and I will move this pointer to the next index, and this pointer will remain same. So I will check which value is smaller. So this is smaller, means smaller or equal, doesn't matter. So I will move this pointer to this pointer. Okay, and move this pointer to the next pointer. And at the end, I will get a merged list. So let's create a dummy head first. So let's see, my values in the list are, okay. So list ij, so values can be negative. So let's put 1001, and also the tracker pointer to dummy node. So now I will move my node 1 pointer till it's not null, and till my node 2 pointer is not null. I will move both these pointers and compare if my node 1 dot value is smaller than node 2, smaller than or equal to node 2 value, then what I need to do here is I need to move my let's say I will store first I will store my next pointer to which my node 1 pointer is pointing. After that I will point my this next pointer to node 2. Otherwise what I will do, I will point my node 2's next pointer to my node 1. After moving this pointer, I will move my node 1 pointer to next position, and similarly node 2 pointer to next position. Also, one thing I can do here is I can initialize next here. Okay. Uh, okay. After the completion of loop, my one of the list will be fully I can say fully transversed, and one will not be null, or both can be fully transversed. In a case where my list which is not fully transversed, I need to attach that list and to the other list. So for example, let's say, hmm, Okay, so I need a tracker. Tracker is on dummy position. Let's rub this. If my node 1's value is smaller than equal to node 2, then what I will do is I will move my tracker dot next to tracker dot next to node 1. Okay, suppose I move here and tracker to tracker dot next. Tracker move here. Node 1 will move to node 1 dot next. Okay, tracker move to next node. Okay. At the end, if my node 1 becomes null, then I'll move my trackers dot next value to node 2 list. If my node 2 list becomes null, I will move tracker dot next equals to node 1. Okay. At the end, I will return dummy dot next. So let's see here. Let's return null for now, and let's see. Suppose here we merge first two lists. List 0 merge lists lists of 0 and lists of 1. Okay, we merge these two lists. Let's see what's the output. What output we are getting. Okay, we do have compilation error. Invalid method declaration. Okay, our method need to return a list node. Okay, and where we don't have a ending node. Okay, let's run. Okay, so let's say we have merged these two lists. So what we are getting 1 1 3 4 4 5. So we are getting correct output. So what we need to do here is suppose this is my answer list. Initially it is null. So what I will do is I will iterate lists for list node L current node current list I can say in lists where I will merge. My answer will be merging answer with the current list, and at the end I can return my answer. Let's see if it's running or not. Hmm, merge lists commands. Okay, let's run four other test cases also. Okay, let's submit it. Okay, so basically this code merges two lists, and we are merging. Initially, we don't have any list. We will merge it with first list. Then we get some output. Then we will merge it with second list. Then third list and fourth list. So this is how we are merging. I think previously I have also submitted this same solution. Yes, it's the same solution, but the code is pretty messy. I was noob coder then, so this is I think a good solution. Okay, so we can I think look for better solutions. If okay, we do have a priority based solution. Priority queue, we have a dummy node for lists for node in while node is not equal to null. Basically, this is not the I think not the as optimized solution as ours. Our solution is better, I think. We do have an editorial for this, but we need a premium. We don't need premium. So let's search let's solve reverse nodes in K groups. We have same definition of a node with the value and next node. Okay. Okay, so basically the question says given the head of a linked list, reverse the nodes of the list K at a time and return the modified list. Okay. K is a positive integer and is less than or equal to the length of the linked list. Okay. Is less than or equal to the length of the linked list. Okay. K is a positive integer less than number of nodes should remain as it is. You may not alter the values in the list node. Only node themselves may be changed. Okay. Okay. Here our value is K. So what we are doing, we are taking group of K element. For example, here we have taken two element and we have reversed them. Then we have taken another two element. We have reversed them. Then we have one element. So how can we reverse a single element? So here we have group size of 3. So what we are doing, we are reversing first three elements. So also we are reversing the remaining elements. So I think we can solve it using the code of reversal English. So okay, can you solve the problem in big of one extra memory space? Okay, let's try. I think we should first write code to reverse a linked list. So reversing a linked list. Let's say we have a counter which is 0 initially, and we initialize a temporary variable, means iterator. Let's call iterator for the head list. While this iterator is not equal to null, what we will do is we will move iterator to the next position. Okay, so and we count number of nodes. We will count number of nodes. Suppose we have got, we will increase our count. So when we come here, our count is 1. Okay, we'll move our iterator to this position. Initially, we are at head. Initially, we are at one position. Okay, so what I will do is I will increase my count and move my iterator. Okay, then what I will do, I will increase my count and move to next position. Okay, so before moving to next position, okay, initially count is 0, incremented count become 1, and I am at second position. Okay, count becomes 2, and I am at third position. Okay, so if my count becomes k, or my iterator becomes null, means if I, in this case my count will not reach k, but my list will reach the null position. So in that case also I need to reverse. Okay, so now I have reached at this position. What I need to do is I need to reverse this list. I think I should also define a current head variable. So initially my current head will be at one position. So what I need to do is now I need to extract this list. I need to extract this list. So I have reached this head position. Initially I'm at head position. So my count is one, let's say. Then I reach this position. Okay, then my count becomes equal to 2. Okay, if my count becomes equal to 2 here, what I will do is I will make my iterator dot next. Let's remove this condition for now. My iterator dot next to null. Now I have this linked list separated 1 and 2. Now what I will do is I will find a reversed group. So what I will do is reverse list, and I will pass current head to it. Okay. Okay. So let's initialize this function reverse list. So I need a previous list node which will be null initially. What I will gonna do is while my head is not equal to null, mm, I will store next variable head dot next, and then point head dot next to previous value and previous to head and head to next value, and at the end I will return previous. So this will be head of my uh, reverse linked list. Okay, and this will also be my final answer because initial head which I have received means in first group swap which uh, received head will be my answer. So okay, let's say list node answer as null and At last I need to return this answer. So my answer will be this reversed group. Okay, I need a boolean flag which is false initially. Okay, so if my flag is false, in that case only I will be assigning the true answer. Otherwise, I will return true. Mark this flag as true. Okay. So we have done reversal for this group. Okay. So now for the second group, if we use this same function for reversal, our previous pointer will be this. Okay. Iterator current head. We are passing current head. Yeah. So let's say we don't modify our head. Instead, we use a iterator. So our current head will still remain at this position, one position. Iterator count equals to k. Current head at this position. Count is one. After we move, our count becomes two, and current head will be at. Okay, sorry. Our iterator will be at this position. Our iterator at this position. Okay, we will set. We are setting iterator dot next as 0 as null, passing current head, past current head, and we will get pointer to this. Assign this to answer if our flag is this. Okay, so value to this one. We need pointer to this one. Pointer to this one. This one's next. What we can do is we can have a previous variable also. Mhm. To initially our counter is 0, so we are at this position and we will increment our counter and move our iterator to iterator to this position, and then counter becomes 2, and we'll move our iterator to this position. So then our iterator to this position. So basically here, when our iterator at this position and previous pointer at this position, our count will be equal to k. So here our here will be our previous pointer and our current head at this position. So what we have done, we have passed our current head. So what we need to do is we need to set our previous to null. So we have set our previous to null. So now we have this list separated. So we will pass this list's head here, and this function will return us 2 and 1, a reversed linked list. So now we have a list which is reversed. So this is the head of the this list. So now what we need to do is we need to assign this one pointer to our iterator. So from where we will gonna get this one pointer. So this one pointer will be our head of the list, which is current head. So what we will gonna do is we will gonna point this head's next variable to our iterator. So here is our iterator. Okay, so we have moved our iterator. Okay, move this to iterator, and so we have what we have done is we have attached this list here. Okay, and now our new current head will be this position. So our current head will be iterator, and now we need to reset our count. So we will reset our count to 0, and at the end what we need to return is we need to return this head. So why I have taken a flag here? Flag is to identify that this is a first reversal. So only when our reversal is first, we will return this value. Otherwise, we will never gonna update our answer. So this will only be updated once. Okay. So we have set our count to 0, and now our current head and iterator are at this position, and our previous is null. Sorry, previous dot next is null. Our previous is at this position. At which position? I think we also need to reinitialize our previous to null. Let's say our previous is null. So okay. So iterator and current head are at this position, and previous is null. So now I enter the loop. I update count. Count becomes 1. My iterator reaches this position. Okay, count is not equal to k. So again, I increment my count becomes 2, and my iterator goes to this position. Okay, iterator at this position, then count becomes 1, iterator 0, count becomes 1 when iterator at this position. Okay, then count becomes 2 when iterator at this position. Okay, now my iterator at this position, and my previous is at this position. So what I will do is make previous dot next is null. I will deattach this part. Okay, and my current head at this position. So I will pass my current head, and this will return me a reverse list. So I will pass this value to my this function, and this will return me a list which is 4 and 3. So what I will do is I will make my current dot head. Okay, current dot head at 5, and move my current head to iterator position, and make previous null and count again 0, and this will not update, but my this pointer will still point to 3. So I also need this variable which was previous tail. So let's call initially tail as null. So after doing all this part, I will check if my tail is not equal to null. And in that case, I need to move my tail dot next to this particular list group, and this will be my tail. Okay, so initially my tail will be my head, and what I will be doing is making. Okay, we also need to handle, I think, for a case when our mm, key is not. mm, how this case is. Okay, Let's see how this case is handled. So here k is 3. So let's take this array 1, 2, 3, 4, and 5. Here k is equal to 3. So initially our this is our head. So our iterator uh, is, is at this position. Our current head is also at this position, and our previous is null, answer is null, and tail is null. So okay. So I will get into my loop and increment my count. So count becomes 1 and previous becomes this, and iterator moves to this position. And as my k is 3, so and count is 1, so in, I will again reach this position. So my count becomes 2, previous becomes this, iterator becomes this. Again my count becomes 3 and my iterator becomes this. So my count becomes equal to k. So at this position, my k is here. My iterator is here. Previous position is here. So I will make previous dot next as null. So I will make previous dot next as null, and I will reverse this. So my I will reverse this part, which will become 3, 2, and 1. Okay, my tail is null, so I will not go into this part. I will make my tail equals to current head. So tail equals to 1, and make my current head dot next to iterator. So my iterator is here. So I will make a bridge here. Current head dot next, and make my current head my iterator, and make previous to null and reset my count to 0. Okay, and we'll check if my flag is false. So if initially my flag will be false, so I will make answer as the this list. So this will be my uh, head pointer. This will be my answer pointer. So this will only be called once, so it will not change in future as we are changing the flag. So moving to this part, I will increment my counter. Okay, we are not reversing rest of the part, I think. You may not alter the values in the list node, only node themselves may be changed. K is a positive integer list. If the number of nodes is not a multiple of k, then left out nodes in the end should remain as it is. Okay, so I think our approach is perfect. So, okay, we have got a submission. Let's look at my previous solutions. So, in June, nearly 2.5 year ago. So, let's see this solution. Okay, I'm using the same concept, reversing a linked list. So this is the reverse function. So basically, number of lines in my reverse functions have decreased after 2 years. So okay, I think this is a pretty same approach, but this code is a bit cleaner. Okay, so I think we can mark this as completed. So yesterday we were not able to solve this problem, LRU cache. So we were using approach of doubly linked list and a hash map. So let's see. Mm, let's remove all the code. Okay. So this is a function to print the linked list. So we will be keeping this function. So I will put this function at the end. So this will work. Okay. Okay. So we have a capacity variable. We have a linked list, a doubly linked list. We have a head of that list, and we have a map which will store a key corresponding to a linked list. Okay. Let's say we only store value in here. Initially, store corresponding value, key value, key value. I think this is the last question in linked list part. So design a data structure, model the concern least listen user concern, visualize the. Okay, we have a get key and a put key. Okay, so a dummy node. Okay, I will check if my map contains this key. If my map contains this key, then it's okay. Otherwise, I will return -1. Okay, so if my map contains that key, then what I will do here is I will find the value of that key, map.get key dot its value. So basically, this will return a doubly linked list, and we will find that value, this value. So at the end, we will return this value. But make this key most recent. So what we need to do here is attach and add at, at start. Okay, okay. We will gonna define this operation. Or our map will not contain that value. So if our map doesn't contain that value, we will simply going to uh, need to add. So we if we will add a value, then in that case we need to reduce its capacity, and if our capacity becomes zero, in that case we will remove uh, the last we will remove the last node, remove least recent node. Okay, we will remove least recent node and uh, add a node at the start. So add a new node at the start. So we'll create a new node, double list. Okay, we'll create a new node, double list, new double list, and we'll give it value. We will add this node to start, and we will also update this map.foot against this key. We will add this node. Okay, if our map already contains this key, then in that case our capacity will not be impacted. So in that case we need to update that key. So what we will gonna do is we will set math.get, we will get that key, uh, that value, and we will update its value to new value, and we will call this same function. This will make the node most recently used key. Okay, so this is the implementation. So we need to implement this function, and this function. Okay, so we will implement these functions tomorrow. Okay, so I think that is it for today. We will still not solving this question. We will solve it tomorrow, I guess. We will implement these functions, or I will look for a better approach if I get some time. Okay, thank you guys.